Hello and welcome to our presentation. This is a presentation for the violin assembly. My name is Kristen.
I'm Eric.
And this is how we put together our violin and our take on everything. So to start off, I did the belly assembly, sub-assembly. What I had to work with is I had to work with the belly front of it, the side, and the lower belly of the violin. The most difficult part about each piece was definitely working with the curves. For the very first one, the workbenches that were used were the sketch tracer and GSD for this part. There were some areas on the violin that the fillet tool was used for to smooth it out a little bit more, but mainly it was the sketch tracer I'd use. The challenges in this workbench definitely had to do with finding the image after closing out the workbench and coming back to work on it. So with that, I always had to select this little tool down here. I'll highlight that. This little tool down here and make sure it was selected, because if not, you can't really view the picture that you're tracing in the sketch tracer. On the next part, I did a plug and a bridge. So for the plug, it was a little bit more simplistic to put together. I had only used Sketcher in this one, and basically used the shaft tool. It was very quick, pretty simple to put together. Same with the bridge here. The bridge was sketched in the Sketcher and then extruded. For the inner design of all of the curves, the spline tool was used. That came in handy, especially using it for the other parts in the belly assembly. So to top everything off, the main challenges of this piece was probably putting it together. Putting this piece together was difficult because all the sketches in the sketch tracer had to make the same part, so making sure that the dimensions on the sketch were the same for every part or accordingly was definitely a big part to take into consideration. And additionally, later when assembling this assembly, the most difficult part was because it's such a curved body, you can't really do surface constraints. So the best way to go about this was to create planes and constrain those. So lots of planes were used in each sketch, and it was constrained accordingly when we were putting everything together. But other than that, just using the surface combine tool to create the curved surfaces on the top and bottom belly was it, and everything else was fairly simple from there.
Hi, my name's Chloe. I was in charge of the bow subassembly as well as the stand subassembly. Right here, we're displaying the bow, so this is the base. This is something called the frog, which will hold the horsehair and connect it to the base point here, and then this is the actual horsehair. This is what it looks like all assembled. It's a bit difficult to tell, but the most difficult part for this subassembly was getting a slight curve along the bottom of the bow here. So for that, I actually just used the multi-surface tool. So it was all just basic knowledge where, to begin with, I started doing this in wireframe, and I realized that it would be a bit difficult to get the curve in, as well as this little tip at the end here. So this assembly resulted being easiest just using our classic KnowledgeWare and Sketcher. The more difficult subassembly was the stand subassembly. There are quite a few parts that aren't included in here. And for this, I used wireframe, GSD, the basic KnowledgeWare, with things such as this bar and the screw being very simple, but for the base here, I had to include quite a few different planes. And for the stand hinges, this was easily the most difficult part. I used sheet metal design to create the base here, which is similar to what we've seen in the past in this class. And then from there, I used the standard workbench to create these little hinges here.
So my name is Eric. I was in charge of the neck subassembly. The neck subassembly consisted of three main parts. First of which were these tightening pegs. And these tightening pegs, we needed 4 of them, so it was pretty simple to duplicate them. I used simple spline tools and a lot of different pockets to generate this curved surface around the each of the pegs, and I was able to easily fit them into the holes in the neck body, which is right here. And then the last piece was the fingerboard, which was pretty straightforward, and we lined that up. I'll show you how in a second. So for the fingerboard and pegs, like I said, the fingerboard, I didn't really use any advanced GSD or any sort of advanced CATIA KnowledgeWare. The splines were used to generate these curved surfaces on the pegs to give it that realistic ergonomic feel. And there were a few challenges in trying to align the fingerboard to that of the neck, but I'll talk about that in a little bit more in a second. So easily the hardest piece that I ever worked on was the neck piece. That's because of this part right here. This scroll can be as intricate and as detailed and complex as we wanted to make it. Unfortunately, that was well beyond the scope of what we had learned in this class. I tried a lot of different approaches to getting the traditional scroll. It's actually represented by a volute spiral and has a variable pitch, and all of these things were very hard to implement using any single advanced CATIA workbench. So I ended up just using a sketch tracer to get the general shape of the entire body, and then applied a variable pitch spiral on top of that in a pad and with a bunch of fillets in order to get the spiral effect. Not quite the same as the traditional spirals, but this one was still within our skill set. So moving on, that completes the neck subassembly, and as you can see, everything fit together quite nicely. I was able to constrain everything using offset constraints and coincidence constraints for the pegs here, and for the fingerboard and the rest of the neck. So fairly straightforward, no challenges in the assembly once I got all the parts designed. An additional piece I did was the tail piece. This is the piece that would hold the strings and the rope from the plug. And we didn't design any of the strings or rope for the plug because it was getting too difficult to take precise measurements, since we didn't have all exact measurements for the pieces we were working with. So I instead used a GSD and a multi-section tool to create the profile of the tailpiece, and you can see how it comes with one profile on one end and gradually goes to a different profile on another. and this was done using multiple sections, and then generated apart using the GSD workbench. There are plenty of plane geometries. Again, there are a lot of different pockets that aren't shown in this view on the underside of here that were necessary to create plane geometries at various angles from the normal orthogonal axes. And so this was a pretty challenging piece, just because I kept running into a lot of errors. I tried sweeping and I tried extruding. I even tried to do this piece just by sketch tracer, and all of those proved to be a little bit more challenging than the multi-section tool, so I just ended up using that one.
So to cap everything for dimension dynamics, we had conducted weekly team meetings discussing what we had done and progressed through. Everyone had their sub-assemblies split up as shown. Myself, Padilla, Captain Chloe, and Stan and Bo. It was overall a pretty good success. The project came along really well, and the turnout was great, except for our strengths. But if we were to actually print this, we would be printing the strengths, so that worked out pretty well.
Yeah, absolutely. So we had not only weekly meetings, but we had kept in contact using Slack messaging, emails, texting. We also had a OneDrive account or Google Drive account that we used all of our files to share with each other with. And since we were in two different sections, it proved to be very difficult to get face-to-face a lot of times. So this really helped us kind of set together our priorities and work together cumulatively. And given more time, obviously we could have gone and done a lot more detail, as any project would allow, but because of the nature of what we wanted to get done with the sub-assemblies, I think it was pretty successful and happy with the turnout.